Moving right along, we are going to move to Geneva Schlepp, who's a civil engineering master's student.
Good evening, everyone. My name is Geneva Schlepp. I'm a second-year graduate student pursuing my master's in civil engineering with an environmental emphasis, and I'm presenting Trash to Energy, Closing the Loop on Landfill Natural Gas. So practically every person generates municipal solid waste, the technical term for trash or garbage. And as you can imagine, we generate a wide variety of waste. So on the left, you can see those types. And traditionally, municipal solid waste has been sent to landfills. And to this day, the vast majority of our garbage is still sent to landfills, as shown on the right here. And based on the EPA's municipal waste pie chart we just looked at, about 63% of trash that is generated is organic in nature, which means it was derived from plants or animals. And thanks to help from microorganisms, organics are naturally biodegraded, which releases gases such as carbon dioxide and methane. The cartoon illustrates microbes eating and releasing methane through a process called methanogenesis, or the genesis of methane. When this biodegradation occurs in a landfill, the gas is simply called landfill gas. And, oh, I think we skipped a slide on accident. Oh, here we go. Okay. Landfill gas composition is variable, but fairly quickly, the majority of landfill gas becomes methane, which is represented by this purple line here on the graph. And it spans decades of a landfill's operational life cycle. Methane is a very powerful greenhouse gas, and if it's released to the environment, it exacerbates climate change. This is why most landfills flare or burn off their landfill gas to convert the methane to carbon dioxide, which is still a greenhouse gas, but about 30 times less powerful, and in some studies, maybe even up to 80 times less powerful as methane. However, flaring landfill gas is a missed opportunity, especially as we're striving to become more creative in our sources of renewable energy. So an alternative approach is to treat landfill gas so that it can be used as a source of natural gas, which supports our everyday energy needs like cooking or heating our homes. So the decomposition magic I was talking about happens in these buried cells at the landfill. The gases are collected and transmitted through the landfill, represented by these red pipes, and it's conveyed to a treatment facility, such as this one in the picture. So a process just like what we just looked at occurs in Maple Valley, Washington, at the Cedar Hills Regional Landfill. The landfill partners with a third party called Bioenergy Washington, which processes the gas on site. And this landfill gas processing, it seeks to purify. Oh, we skipped a slide again. There we go. Sorry about that. Keep skipping over. The landfill gas processing seeks to purify this gas and reduce the water content. And this is in hopes to minimize the impacts in a pipeline to bring the gas to us. So to create this pipeline quality natural gas that's fed into Puget Sound Energy, they run through this series of treatment processes as well as additional treatment processes here. A byproduct of this gas purification is condensate, a wastewater generated during the condensing of this gas. And when water condenses out of the gaseous phase, it brings contaminants with it that are present in the landfill itself. And this is where my research comes in. So since January, I've supported Dr. Gregory Korshin's research team to optimize a novel treatment technology to remediate this contaminated landfill gas condensate. Our target contaminant is organic arsenic, but the technology is also applicable to other contaminants of emerging concern. There's limited research on remediation techniques for specifically organic arsenic, which makes the work very exciting and applicable to other landfill gas operations that potentially or are struggling with contamination of this nature. A published alternative that I've included a snip of here shows that reverse osmosis can also be used to treat contaminants of this nature. However, we believe that the technology that we're optimizing is a much better approach moving forward. So that's very, very exciting. And to wrap up, opportunities for waste to energy. In our ever-growing world, finding reliable sources of energy is only going to become more important And coupling that with our global energy needs, with a serious need to curb greenhouse gas emissions, landfill gas to energy is a necessary step forward to harness this source of renewable energy. And while there have already been 500 landfills or more implementing this landfill gas to energy project type, the EPA has identified 463 more landfills as candidates, as shown on the map. My research with Dr. Korshin is exciting because we're supporting renewable energy and removing contaminants that would otherwise be harmful to human and environmental health. And I'm confident that as this research is piloted at Cedar Hills, other landfills with similar issues will benefit from this technology. Thank you all for listening.